Hey there, welcome back to Project Syntar. In the last episode we discussed the kelp forests of Aurelios. They were very unique with lots of cool fauna. In today's episode, we will be leaving the shallows and venturing to the deep dark depths of Aurelios's oceans and discussing the organisms that inhabit these crushing depths. With no light, no plants can exist in these ecosystems. With no plants, no herbivores can exist in these ecosystems. With no herbivores, no hunters can exist in these ecosystems. But that isn't actually the case. I don't blame you for thinking that, however. There are two major sources in which energy and nutrients can enter these ecosystems. One of them is through hydrothermal vents. Hydrothermal vents typically occur along the ridges of tectonic plates where lava and chemicals flow into the water through vent-like rocky structures. These chemicals can be extracted by extremophile bacteria-like organisms called chemotrophs. These chemotrophs can be then eaten by filter feeders or harvested by other organisms to make energy for them. In turn, this lets hunters and carnivores persevere. This creates a unique ecosystem of almost blind extremophiles that live in dispersed odd pockets throughout the planet's deep oceans. The other way energy can come into these ecosystems is from the surface. Once an organism dies, they get eaten by surface-level scavengers, but if they don't get eaten in time, then they fall down to the dark depths of the ocean. Whether it's a huge whale like Antigrophilonas, smaller fish like Simonosarian, or even dead planktonic marine snow, it will be a source of food for organisms to take advantage of. And where there's marine snow, there are chordacanoas. Some resilient species of the ancestral chordacanoa could persevere at certain depths, but some may specialize for these depths. They may lose all pigment, as that has no use at these depths. This is because there is no light, which means they cannot be seen anyway. Another adaptation they may gain is an enlarged eye, which lets them take in the tiniest bits of light that make it down, although that is still incredibly limited. Without a proper way to sense their environment, they may gain a new one, chemoreception. Briefly discussed in episode 4, it's a mix of smell and taste and lets them sense chemicals in the water. Since all organisms produce chemicals, this lets them sense their predators, often before the predators sense them. This creature, I shall name Cordugigus, is much larger than its shallow-dwelling counterparts. This is because of deep-sea gigantism. Deep-sea gigantism is caused by two things. 1. The larger a creature is, the more volume compared to surface area there is, which in turn means it warms itself up through gigantothermy. The other reason deep-sea gigantism happens is because larger organisms are more efficient than smaller ones. This is like how a cat is 100 times larger than a mouse but only needs 32 times more food. All of the organisms in today's episode will follow the trend of deep-sea gigantism. Another creature to take advantage of the marine snow would be the Simonosarian. This creature is going to be called the Pelistoma and thrives in the abyssal seas. They have evolved a thin membrane of skin between their bottom to feeding parts. This earns them their name, which means skin mouth. This is to catch marine snow that is falling from the surface. It then folded its arms into its mouth and sucks the marine snow off of them. Its top two limbs have evolved to produce a blue light at the tips of the tentacles. They flash these on and off in different patterns to communicate stuff like danger, an absence, or abundance of food and injury. They also do this to sea, however this only works to a certain extent. Like the Simonosarian, they travel in groups. In the deep sea, JT is virtually black, meaning the groups look like a large cluster of bright blue stars flickering on and off in the cosmos, a truly alien wonder. Let's move away from microscopic organisms falling from the surface and discuss something bigger, much bigger. Whale fall is when large creatures from the upper levels of the water column die and fall down to the dark depths. On Aurelios, these creatures will most likely be Antigrophilonas, Echinotherium, Titanopisces, and Tunomorph. A few clades of organisms may specialize in eating mainly whale falls. One of these organisms is the Chordulumino. This disgusting-looking critter has descended from the Chordacanoa, specifically Chordacanoas bilaterus. It travels the vast expanse of the ocean floor looking for whale falls. To travel longer distances, it has gotten bigger. This also helps with combating the freezing cold of the depths. They have lost the webbing/skin between the needles it used to move around, giving it an RIO centipede-like limbs. It also has a very notable adaptation, a bioluminescent strip on its back. It only ever flashes its strip on during one occasion, the occasion being when they find a carcass. This helps other members of its species to find the carcass. This also lets other members of its species know where they are so they can mate. Once mated, the Corgulumino will lay its eggs in a hole beside the carcass. This ensures they have some food once hatched. The Corgulumino's weak jaw prevents it from eating tougher tissues like bones, so they only eat the soft parts and leave the hard parts for other scavengers. One of those scavengers being the Luminocyclops. Some Cyclopsippus have lost their niche of benthic scavenger in favor of being a deep-sea scavenger. They have gained a deep red skin since red light disappears first in deep oceans, so things that are red are effectively black. They have gained more segments on their shell to swim fast and travel longer distances. Due to deep-sea gigantism, they are around 2 times bigger than their shallow water relatives. They travel across the seabed, looking for a whale falls, often following groups of Corgulumino since they are going to the same location. Once there, they use their crushing bite force to crush open the bones and harder tissues of the whale fall. Once arrived at a carcass, they do something similar to the Corgulumino, in which they flash their lights on and off in a pattern to show that there is food here, and so they can congregate in groups around the carcass to mate. The third and final creature to search the ocean depths for a whale fall is called the Abyssitherium, name meaning abyssal beast. Some Echinotherium have descended to a lower level of the water column to feed on the whale falls. They have gained a dark red color since red is the same as black at these dark depths. Again, they are larger than their open ocean counterparts. They now reach sizes of 10 or even 13 meters. Abyssitheriums traverse the seabed in search of whale falls, and when they find one they claim in and eat as much as possible. The other whale fall scavengers don't cause too much of an issue, but if an Abyssithium finds themselves at the carcass of another Abyssithium, they will fight until one of them either dies or retreats back into the ocean to most likely die of starvation or blood loss. These fights are often gruesome and deadly since neither beast can afford to lose a carcass. When traversing the sea, they occasionally take a snack of Palistoma if they can get their jaws on them, or a Cordugigas. To sense these, they have gained electrorecepting cells at the tips of their snout. They use these to sense electrical signals in the water, electrical signals which all creatures produce. This lets them sense their prey in the pitch black. Their eyes have almost entirely reduced. Their only function is to see the bioluminescence of the Corgulumino and Luminocyclops, which indicates a whale fall. One of the most well-known uses for bioluminescence is as a lure to attract prey close to the mouth of a deep-sea predator. This is seen on the female anglerfish of Earth. Aurelioses representative of this trend are called Deceptostoma, and have evolved from Gladiosidae. They have lost the blades on their top to mandibles in favor of having 2 large, bright blue glowing pockets at the tips. They use these to mimic Pelastoma's lights, so look just like them. They also mimic the light of the Luminocyclops to lure in the before-mentioned Luminocyclops as well as Corgulumino. Since the prey can be coming from any angle, they need to be able to turn to any angle as quickly as possible. To do this, they have gained many segments and lost their fins since they could get in the way of a sharp turn. Since mates are incredibly hard to come by at these depths, if found they will constantly mate for up to 30 minutes and then the male will die. The female will then lay the thousands of eggs inside the mouth if the male, ensuring the young have a food source when they hatch. Now we've covered dead organisms falling the seafloor, whether that's whale falls or marine snow, and who eats them. We need to cover the other method of nutrients entering the deep sea, hydrothermal vents. The start of the hydrothermal vent food chain are microscopic clouds of chemosynthetic bacteria-like organisms. They surround the hydrothermal vents and convert the chemicals into energy that they then use to reproduce. Some Infernophyta who live in these depths may swap photosynthesis for having a symbiotic relationship with some of these bacteria-like aliens. They would keep the chemotrophs inside their bodies. They chemotrophs will give the plants nutrients, whilst the plant will protect the chemotrophs from filter feeders and the extreme environment. They will coat the floor of the vents in a bright colorful mat since the chemotrophs will take on many different colors. For this symbiotic relationship they have earned the name chemophyte, meaning chemical plant. Another organism to take advantage of the chemotrophs is the Testalances. These have descended from the Zoilosances and now filter the chemotrophs from the vents, growing as close to the tip of the vents as possible. The vents environment is very dangerous and unpredictable, especially temperature-wise. It turns from freezing cold to boiling in seconds, so it is beneficial for the Testalances to be protected from the elements. It does this by gaining a shell. All these chemosynthetic bacteria would create a mat of marine snow around the hydrothermal vents. This, along with the chemophytes and chemosynthetic microbes that reside of the seabed, will create a perfect food source for many creatures. One of the first creatures to take advantage of these would be the marine snow-eating bilotworms. Already being somewhat predapted to the extreme environment by burrowing, it would be a no-brainer for some species to adapt to this environment. Already being protected by the extreme tongue with their burrows, they may adapt their mouth to have an extra chamber inside to store marine snow and expel water. This makes them even more efficient at consuming the marine snow. They may also lose their external locomotive parts since burrowing animals tend to have little to no external parts. Being at such deep depths, they may also minimize their eyes. In many species, the eyes may not even be present. These creatures shall be called the serpentivermis, meaning serpent worm. Some marimivermis may also adapt to these deep depths. They may live around the hydrothermal vents, eating the marine snow from the floor. They may do this by extending their mandibles to shovel their food into their mouths, giving them a signature wide-mouthed look. They may also become pale and blind due to reasons we've discussed previously. To survive the extreme tongue of the vents, they foster the growth of chemophytes on their backs. These plants protect them from the extreme temperature by shielding them and insulating them. They do this by growing extended hairs on their backs to incentivize the plants to grow there. This allows them to come in a vast range of colors. Due to their wide mouths, we will call these creatures the Widastoma. All the chemobacteria will be eaten by filter feeders. Some of the only filter feeders in these depths are the microscopic Tesseragones. Some may adapt to live exclusively around the vents. Due to their no-light environment, they may lose their basic eyes in favor of chemosynthetic cells all around the lips of the mouth. They will have a huge gaping mouth, and they will use this like a basking shark, opening it as wide as possible and swallow the clouds of plankton. They may also lose the basic fins as they aren't needed anymore. Their segments may fuse into one long eel-like body and the tip may gain a tail. An interesting adaptation is green blood. So far, every time blood has evolved on this planet, it has all been coincidentally red iron-based blood. However, in the cold deep sea, it may be favorable to evolve green blood. This gives them a pale green coloration which is very unique. It will be called the vertivermis, meaning green worm. With all this prey, some carnivores are bound to emerge. One of them may evolve to feed on the Testalances, becoming the Crunchastoma. After the Zoilosances have moved down to the vents, their predator, the insanivorum, is soon to follow. Its ancestral scissors-like motion of its sharp-bottom mandibles won't any nearly enough to crush the shells of Testalances, so they may adopt a crushing motion. They may thicken and widen the mandibles, as well as gaining stronger muscles around the base of the mouth. They have again adopted a reddish coloration to blend in with the deep, and their eyes are almost vestigial, both for reasons stated previously. The final carnivore and creature for today will be the apex predator of the vent ecosystems, the Penacostoma. This frightening-looking fellow has descended from the Deuxanopod when their prey, the bilotworm, evolved to traverse the dark depths. They have adapted their prong-like mandibles into pincers to pluck prey from the seabed of the vents. They have flattened and stiffened their feet into fin-like structures, so they swim with fin-paired swimming. Their eyes have been completely lost on favor of having chemoreceptors lining their backs and the tips of their mouths. With that being said, The vent ecosystems as well as the open deep sea ecosystems have been discussed and explored. Today we have discussed glowing eel-like arthropods, huge prowling scavengers, rainbow chemical plants, huge green-blooded worms, and much more. It would be impossible to cover every single vent and every single trench, so take today's episode as a brief overview of the planet's deep seas. Thank you for all the people who have contributed fan art for the episode. I appreciate it a lot and it makes the episode look 10 times better, so thank you. There will be a fan art montage at the end of the vid. If you would like to make fan art, see some sneak peeks of the next episode, generally chat or much more, you can join the Discord server in the description of the video. In the next episode, we will dive into the lakes, ponds, rivers, and streams of Aurelios and plunge into their freshwater ecosystems. Thank you so much for watching all the way to the end. I really appreciate it. Thank you and goodbye for now.